for P waves, those are going to be those pressure waves. So the primary wave describes how quickly that wave travels, and then the pressure wave, the primary wave is quickly, pressure wave is how it travels through that rock. So show me a back and forth motion that we talked about yesterday. Think about a rocking chair. So you're going to go forward and back. Okay? So imagine as that, if you had a slinky in your hand and you were to push it and then push it again, you would see those waves travel down that slinky like at the bottom of your page. Okay? So it's going to stretch it and it's going to squeeze that rock. And then we have the P waves have the ability to travel through solids, liquids, and gases, which means that they can travel through all layers. Okay? Yesterday what I did was I read a, give me a thumbs up if you're with me. Everything's good? All right, cool beans. So I am going to read a paragraph out of the textbook about S waves. Same thing we did yesterday. Open up your chat feature. I'm going to read through the paragraph, and I want you to write at least one piece of information, one property that you can catch about an S wave, okay? The more the merrier, because then I can scroll through and see what we know and what we don't know, okay? So this is going to be about S waves. Rock can also be deformed from side to side. After being deformed from side to side, the rock springs back to its original position and S waves are created. S waves, or shear waves, are the second fastest seismic waves. S waves shear rocks side to side as shown in figure 4, which means they stretch the rock sideways. Unlike P waves, S waves cannot travel through parts of the earth that are completely liquid. Also, S waves are slower than P waves and always arrive later. Thus, another name for S waves is secondary waves. Perfect. I'll let you finish up your thoughts on the chat. Hit enter. And then, here's what I would like. Ooh, you guys are nailing that. Keep going. All right. So let's go ahead and start. We're going to follow the same pattern we did with our notebook for primary waves. So what is the name, another name for S waves that describes its speed? Go ahead and drop that in the chat. What is the second name for S waves that describes its speed? Perfect. You guys are saying secondary waves. That's exactly right. So under the S waves, I'm going to write secondary I'm going to write outside of my page. I write too big, but it's okay. So, what did they say about when it arrives? If it's a secondary wave, go ahead in the chat. What does that mean about when it's going to arrive? Give me like an order. Very good. They always arrive after. They arrive second fastest. Very good. So we're going to put arrives after P wave. Oops, a little squished in there. Which means instead of fastest, it's going to be second fastest. That's sideways. All right, perfect. Okay, so now we know that another name for an S wave is a secondary wave because it arrives after the P wave. So think about a race. P waves are going to come in first. S waves are going to come in second. Okay, when we can think of S waves as maybe those people who always arrive right on time, not a minute earlier, not a minute later. Drop who you can think of in the chat who always arrives right on time. my gosh, some of you are saying nobody. Either on time or late. All right. I see a couple of you guys in there saying that your classmates arrive on time. I dig it. All right. So then let's go ahead and continue with what is the second name of an S wave? What is the second name that would describe how the rock moves? And I'm going to change my color. Very good. So shear waves is exactly it. So it's going to be SHE. Now I'm going to double check just in case. AR. So those are going to be called shear waves. I always liked when Mrs. Shear was in my class when I taught this because she thought the whole lesson was about her. So if you're in my 6th period, you'd appreciate that. Miss her. Okay, so then what is that motion? So for pressure waves, it was back and forth. What is the motion for shear waves? Very good. It's going to be side to side. So if you're sitting there, show me what side to side would look like versus back and forth. Exactly. Show me P wave. S wave. Some of you just look dizzy. Very good. Awesome. So these ones are going to be a side to side motion. Okay. And then what do we know? What do we know an S wave cannot travel through? Drop that in the chat. What do we know an S wave cannot travel through? So, complete liquids. Now, think about what part of the earth that is completely liquid. And it's when it's talking about its physical properties, one of the 5 layers. Okay, if I go back. Which one of these layers is completely liquid? Okay. Perfect. You guys are saying the outer core. Now, we know that the asthenosphere and the mesosphere are the mantle, and it's solid rock that is the ability to flow. So it is still a little bit more of a solid, but the completely liquid. So we now realize that an S wave does not have the ability to travel through the outer core, which is why when we look at this picture in our notebook, when it hits that outer core, they bounce off. They travel differently. Okay? So when we go back to our S waves, we're going to say that it travels through really it would just be solids, gases. Okay? So then really, an S wave can only travel through what 2 layers of the Earth? If we think crust, mantle, core, if it can really only travel through solids because there's no gases really in the middle of the Earth, we have our atmosphere. Very good. So it's only going to be it's only going to travel through crust and mantle. Okay? Give me a thumbs up when you're ready to move on. Cool. Okay, so the last piece that we're going to talk about are the surface waves. Okay, I'm going to go back to my textbook. Same thing, bring up the chat. As I read my paragraph, drop at least one piece of information in there that you hear. Okay. Hold on. Nope, never mind. All right, so surface waves. Surface waves move along the Earth's surface and produce motion mostly in the upper few kilometers of the Earth's crust. There are two types of surface waves. One type of surface wave produces motion up, down, and around, as shown in Figure 5. The other type produces a back and forth motion like the motion produced in an S wave. Surface waves are different from body waves in that surface waves travel more slowly and are more destructive. Okay? So those are surface waves. And I'm going to tell you what, surface waves is what when you see videos of earthquakes or you see news stories of earthquakes, what you are seeing is more than likely the surface waves and the destruction they're doing. Because again, it's going to be right on the few upper kilometers, so really upper couple miles of that crust, okay? So the first thing that I want you to tell me is how many different types of surface waves are there? Okay, so we are going to do the different, we're going to do some labeling on this picture, okay? So up here in the corner, I'm going to write two types of waves. So we have two types. Okay. Those two types are going to be the back and forth okay. I'm not a huge fan of how they describe the waves and the two different paragraphs because if they say that it's like an S wave, then it really should be the side to side, right? Because when we talked about P waves, we talked about back and forth. So I want you to know that you do not necessarily have to know the difference between these two. Okay? The biggest thing is how destructive they are and the speed. Okay? So this is a little bit extra information for you guys, but I think it helps you understand what's going on. So we have our back and forth, which is going to be this blue line. Okay? So that one's like this. So again, it's moving that rock side to side. Okay? And that is called a love wave, literally L-O-V-E. You do not have to memorize this either. My guess is the guy who discovered it, his last name was Love. That would be my guess. Okay? Justin, quit messing with your computer screen. It's distracting. And we know my attention span is not very big. All right, so then our second motion is going to be, this is the crazy one, okay? It's going to be up, down, and around, okay? And that's going to be the black arrows that you see on the inside, okay? And those ones are called Rayleigh waves. R-A-Y-L-E-I-G-H. Okay? So again, those are just some fun facts for you. But when you think, okay, I'm going to let you write that. But I want you to think about how in the world you're going to go back and forth, up, down, and around at the exact same time. Okay? So if you were to take your pencil, hold it up in the air like this. Okay? Notice how I have it sideways. Okay? So really, it's going to be back and forth, which is our side to side, right? And then it's going to be up, down, right? Because it goes, right? And then it goes up, down, and around. So this wave is traveling through the earth, through the rock, and it's moving it and shifting it in all those ways. So when you see these buildings collapse or these structures collapse, it's because it's destroying that foundation. So that's why these are going to be the most destructive waves, because of all those different directions that the force, the energy is moving it. So we're going to put properties over here. I'm going to use green. Okay. And because it goes in all directions, how can we describe its force? Go ahead and drop that in the chat. If it goes in 4 different directions, how can we describe the force from a surface wave? Ooh, I like that you threw unbalanced in there. Strong, nice. Everywhere. Highly destructive, beautiful. Nice. All directions, strong. So these are the ones that you're going to see the majority of that destruction from. So we are going to say most destructive. Okay. And it is most destructive because it moves along where? Where do surface waves move? Drop that in the chat. They move along blank blank. Nice. Very good. Earth's surface. I'm not going to lie, I miss my whiteboard. I miss our doodle sessions. I miss our discussions. All of it. But I am blown away at how many of you are here today, and this just makes my teacher heart so stinking happy. You guys are rock stars. I appreciate you. I'm getting off topic. We need to finish. Okay? Good day. So, last but not least, how would you describe the speed of a surface wave compared to the other 2 waves? Drop that in the chat. Be specific. Like late. They would be the late people. Very good. So these are going to be the slowest waves. Slowest. That looks weird, like it's not a real word. Okay. Beautiful. So, who would be a surface wave? Who typically shows up late? Some of your names of your friends are inconsistent. You guys crack me up. Awesome. Some of you realize you guys are the ones that are late. I appreciate that. Self-awareness. Okay? Ooh, some of you are getting... How many of you know you're the late one? All right, that does match with some of those private messages I just received. You guys crack me up. Okay, so give me a thumbs up, sideways, or down on how seismic waves are going. Okay, so that is our entire section. Okay, next week we're going to do discussions, review, and more than likely an assessment at the end of the week. Okay, it will be on Canvas. It will be set up that you can take it multiple times, okay? But obviously, I want you to challenge yourself the first time, try to take it yourself. We're going to go over the layers of the Earth, the descriptions of the Earth, the order of the layers, surface waves, P waves, S waves, the order those go in, so on and so forth, okay? And then after that, I believe we only have one more section of science, which are going to be the tectonic plate movements. And I will be putting a packet out at the front of the school if you want a color copy. But if you can print a color copy, I'll put it in a file as well. So we'll have one more thing to cut and glue, and that'll be the end of 8th grade science. Okay? So, I know, right? You guys are rock stars. We almost made it through this year. We're almost there. So, give me a thumbs up, sideways, down on how you are doing personally. I didn't even ask you a question. You all threw your thumbs up. Don't be trying to quiet me so that I'll just leave you alone. Okay? I want you to go read this a couple times. Monday, there's going to be a little review to see what you can, what you grasped. And I will see you guys on Zoom on Monday. Okay? Cool beans. Make sure your first and last name is in the chat. If you did it at the beginning, you're perfect. I don't think anybody else came in, but you guys should be good. Okay? I appreciate you. Have a fabulous day. Happy Friday. Have a good weekend. Bye. I miss you already. Still. Always. Forever.